Second artifact I'd like to share with you comes from EdTech 542. And again, like 502, it's not a specific activity within the course that I'd like to share, but more what I took away from the course as a whole. A little background information to set the stage first. I just completed my first year of teaching in a mastery-based learning environment. I was working for Quality Schools International, and they have developed their own curriculum for all their K-12 courses and age levels. They took each year-long course and divided it into 10 units. Each one of these units was then had a number of standards or objectives that each student was expected to be able to master before they could progress on to the next unit. This created a number of challenges for me personally as an instructor. It seemed very much like teaching to the test. It was very difficult to get students engaged in creative problem solving, and really created quite a process, frustrating process for me as I went through the teaching for mastery iterations of instruction and assessment, followed up by either enrichment if they had performed well, or reteaching and reassessing if their performance was not up to the level of mastery. Again, became a repetitive process and really took away from the course for the students as well as for myself. Specifically in geometry, this really created a number of shortcomings for me. As an instructor, it became difficult to really show how the course itself could reach out into all these different fields. You could virtually find a content or a topic that students really enjoyed personally, and you could tie it back to something in geometry. So it really shortchanged the students. It took a lot of the fun out of the course and the real application. It made it very difficult throughout the middle of the year trying to really keep students engaged. After completing that first year of teaching, I took EdTech 542 the following summer. With the project-based learning model that they use, had a phrase called begin with the end in mind. And this focused on determining that long-term objectives. What's the end goal? In this case, for the courses I was teaching, it was the standards that were laid out for the units. And then working backwards from there to determine how to engage students and show that they can achieve those objectives. Very similar to the process called reverse engineering, where you start with the final product that you have, and you work backwards to figure out how it was created, how it was made, and the steps that needed to be gone through in order to recreate it. With the standards that were laid out in the curriculum, it set the stage very well, working within the framework of the project-based learning model to tie these standards to broad perspective projects that really contained real application, that developed some real meaningful real-world application for students. And this is something that definitely I took away from the course and the program as a whole, of how to engage students in something more than just mathematical steps in a class. It really helped to see how all these little pieces of a puzzle fit together to create a great work of art, or in this case, hopefully for the students, a great learning experience that was meaningful and engaging. And the biggest factor in this was to move away from just focusing on students being able to do the mathematics, but instead through the projects that they were engaged in, to focus on the higher order thinking skills, the planning, the creating and analyzing what they had created from a mathematical perspective. Really helped develop a sense of how integral mathematics is to so many different areas of content.